Ladies and gentlemen, today I'm so excited to share with you my first video in a long series where we'll be learning all together the, the basics of data structures and algorithms. So without further ado, let's get started with our first problem. So our first problem is the two sum. So given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. So for our inputs, we'll have an array of integers and a target integer. And we need to find two numbers in this array that they add up to the target. And we need to return their indices. Pretty straightforward so far. You may assume that each input would have exactly one solution. So here we assume that there is only one solution. That means that if we find a solution in our algorithm, we can stop it and return the solution. And you may not use the same element twice. That means in our solution, we can't have the same index in the result. That would be totally wrong. You can return the answer in any order. Okay, so now let's see some examples to have a better understanding of the problem. So here we have two, for our first example, we have 2, 7, 10, 9, 12, and we have 20. The answer here is 10 and 12 because 10 plus 12 is equal to 20. But we need to return their indices. The index of 10 is 2, the index of the 12 is 4. For the second example, we have 2, 1, 5, 4, 6 in our array and the target is 8. The answer here is 6 and 2 because 6 plus 2 is equal to 8. But we need to return their indices. The index of 2 is 0, the index of 6 is 4. For our last example, we have 2 and 2 and the target is 4. So the solution is obviously 0 and 1. 0 and 0 is also, if you use the same element twice, it will also be equal to 4, but that would be a mistake because in the definition or problem, we can't use the same element twice. So this is wrong and we need to pay attention to that. Now, how are we going to approach that? For the first solution, it's better to have a brute force solution. Generally, it's not the best one, it's not the most optimized, but it's better to have this approach at first. Okay, so how are we going to do that? So first of all, I'm gonna choose the first number. It's 2. Then I'm going to look at the target number and subtract 2, so 20. Now I need to find 20 in this sub-array. Is there any 20 in this sub-array? 7 is not equal to 20, 10 is not equal to 20, 9 is not equal to 20, 12 is not equal to 20. So now I need to move to the next number, that is 7. And then 22, I subtract 7 from 22, it's 15. Now I need to find 15 in the rest of my subarray. Is there a 15 here? 10 is not equal to 15, 9 is not equal to 15, 12 is not equal to 15. So I need to move to the next number. And I need to subtract 10 from 20, so 12. Is there any 12 here? 9 is not equal to 12, but I find my 12. So actually the solution is 10 and 12. And as I said, I must return their indices. So 2 and 4. That's great. And actually we can do it in the other way around. That means we instead of checking the end subarray, we could check the beginning subarray. So at the left, and we will have the same outcome. Now let's try to code that. So first of all, we will need our first loop. then we will need our second loop. And here we must not start from I, because if we start from I, we will have, in some specific cases, a solution with the same element, and that would be wrong. But by doing +1, we're sure that we're not going to select the same element more than one time. And now we need a condition. We need to check if the nums I plus the nums j is equal to target. Yes. And if it's the case, return their indices. Oops. And if we don't find any answer, return null. Okay, cool. Now let's check, let's run the code. Okay, that works. We submit it. And it works. And I have here 97 milliseconds, and that's actually a lot. Because if you saw, we had 2 nested loops. That means that the time complexity would be O n squared. The space complexity is O of 1. Okay, can we find a better solution? Yes, actually yes. And sometimes to find a better solution, it is choosing the right data structure can help us. Okay, and the intuition that we could have here is that we have been going through the same elements so many times. So can we have a data structure that will allow us to have an easy and a really fast access to our elements? You have 3 seconds to think. 2, 1, 0. Yes, there is actually the data structure that will allow us to do that, and it's a hash table. A hash table or a hash map will allow us to put our elements in a O1 time complexity. So put and also get our elements in a O1 time complexity. And it's actually a table of key and value pairs. So so the first thing that we're going to do is that we're going to put all the elements of our array in our hash table. And actually, we need a hash table and not a hash set. So in a hash set, we can only put keys, but in a hash table, we can put keys and values. Why? Because in our problem, we will need also to return the indices of our numbers. If we had like just to return the numbers themselves, a hash set would have been sufficient. But in our case, we need also to return their indices. So that's why we need a hash table. So let's, our first loop, we're going to put our elements in our hash table. So here 2 and the value is 0. So here we have the index and here our number. So in a 2, 7, 10, 9, 12. So 7 is 1, 10, 2, 3, and 4. Great. Now we have all our elements in our hash table. Cool. Now the second loop, we're going to loop through all the elements, and at each iteration we need to check if there is the complement number here. Okay, so let's go. 2. 22 minus 2 is 20. Is there any 20 here in the hash table? No. Okay, we go to the next element. 22 minus 7 equals to 15. Is there any 15 in our hash table? No. Okay, we go to 10. 22 minus 10 is 12. Is there any 12 in our hash table? Yes, we find it. So what we're going to do, we're going to return the current index, so of the 10, that is 2, and also we're going to return the value of that key, that is 4. So we're going to put 4. So let's try to write the code of it. I'm gonna delete everything, and okay, so first of all we need to declare a hash map, and we will have an integer, a key, the key and the value, 2 integers, and I'm gonna call it map, new hash map. So the key here would be the number, and the value would be the index of that number on the array. So as I said, the first loop, we're going to put all our elements in our hash table. So map put, we put the nums I and the index I. The second loop, we check, we're going to check if the complement is in the map. So the complement is the target minus nums I. If the map get or contains key of the complement, what are we going to do? We return new int of I, and this time we need the value. So we need the value of the key complement. That's why we're going to do it like this way. And if we don't find any solution, we're going to return null. Well, actually, you might think that is correct, but actually there is a mistake. Because if you recall, in the definition of the problem, we must not have duplicate the same element on our result. But in our case here, we could have the same element used multiple times. So how are we going to avoid that? Is by adding a condition here. We need to make sure that the elements that we are using are different and have different indices. So map dot get, we're gonna get the index of that complement and make sure that it's not equal to I. So with this condition we are sure that the two numbers are different or distinct. Okay, now I'm gonna run the code. If hopefully it's correct. Yeah, I'm gonna submit it. Okay, this time it's 8 milliseconds. Okay, so that's actually quite fast. So yeah, this time we've had 2 loops, but were not nested. So the time complexity of a program was O(n). But this time we had to use a hash table. So the space complexity is O of n. In the brute force approach, we had O of 1, but this time it's O of n. That's great. Now, can we improve once again this solution? And the answer is yes. The first loop is actually not necessary. I'm gonna remove it. Okay, so here we're calculating the complements, and then we are checking if that complement exists. Okay, and if we didn't find the solution, we can just here add the complement, and it's going to be correct. And if I run the code, map put, not the complement, the nums I, my bad. If we didn't find a solution, we add the nums I to our map. Yeah, I forgot about the index, sorry. Okay, and we put the index, so we put our number and its index, and we submit. It's going to be correct, and it's this time 4 milliseconds. Wow, that's faster. But here this condition won't be necessary, because we haven't added yet that number. So we are sure that this case won't happen. So this condition will be always verified and true. Yeah, it's still correct. And actually this time I got 1 milliseconds. Yeah, so that's it. Hopefully you've learned something, and see you in the next video. Goodbye.